So hello all of you. Today we will start with the basic programming of 8086. Till now we have studied the architecture of the microprocessor, different addressing modes and the instruction sets. Okay. So now here is the time to go towards the 8086 basic programming. So first we will see the basic programming and then we will go for some interfacing and some advanced programming. Okay. So let's start. So first we'll go for the 8086 program to add the two 8-bit numbers. So very basic program we will start today. So what is the program statement exactly? So write an assembly language program to add two 8-bit numbers stored at address 2050 and address 2051. In a 8086 microprocessor, we can say 8085 microprocessor. The starting address of the program is taken as a 2000. Okay, so we will take here. So starting program or address of the starting is a 2000, and we are taking two numbers. Okay, one is stored in a address of 2050 and another is stored at the address of 2051. Okay, so let's start. So here's some diagram that I have given here. So here, uh, so first, uh, b- uh, the first bit is stored at the address of 2050, that is nothing but 3b hexa. Okay, and another memory address, the second number is stored at the 2051 at the that is 5 F9. Okay, so there are two numbers which are stored at this address location. So numbers are this. So actually this is the data and this is nothing but the address location. Now here we are going to store the output or a result, that is we are going to store the result at 3050. Okay, the result is suppose 34, that is going to store at the, and whatever the carry is generated which is stored at the 3051. Okay, so let's start with the actual algorithm. So how exactly the flow of our program? So first what we will do, first we will load the first number from memory location 2050 to accumulator. Okay, what is the first step? First what we are going to do, first we load the first number, okay, from a memory location 2050 to accumulator. Okay, so whatever the number stored at the address location 2050, that we are going to move into the accumulator. Okay, so next step, move the content of accumulator to the register H. Okay, so move the content of accumulator to register H. So whatever the content in the accumulator, that we are going to store in the register, that is H. Now load the second number. Okay, now first number is loaded. Now go for the second number. So now load the second number from memory location 2050 to accumulator, right? So what we have done, the first number we have stored in the accumulator, that we have already moved into the H. Now accumulator is empty. Now we are moving the second number into the accumulator. Now then add the content of the register H. Okay, what register H is having? Register H is having the number first. Okay, so whatever the number first, that is having in the register H, and what is the accumulator is having? Accumulator is having the number second, right? Whatever the second number, that is having the accumulator. Now we are going to add that register H and accumulator, means number first and number second, using add instruction. Okay, so very simple instruction, that is add instruction. And now where the result is going to store? The result is going to store at the location of 3050. Okay, now if the carry is generated, generated in the recovering using the ADC command and store at the memory location 3051. Okay, so whatever the addition or whatever the carry is generated, that is need to be added, because we are going to do the addition. So we are using the which instruction? Add carry. Okay, add carry. So this is how the flow or algorithm of the program. Now we are going to see exactly how the program will be written in the assembly language. So here I will write the program. So here first address is taken, whatever the mnemonics means what exactly the instructions, okay, how the instructions will be, and that is shown the command. So actually this part is important for us for the programming coding. So first, what at the starting of the location is what? 2000. So LDA, that is a load instruction. So first we will going to do, first we load the address. Okay, so whatever 2050 address we are going to load in the instruction or in the accumulator. Okay, so sorry, whatever the number is stored in the 2050. Okay, whatever is the number stored at the address location 2050, that we are going to move into the A. Okay, so that is load 2050. So whatever at the location of 2050 come into the accumulator, that is A. Now we are going to move that A. Okay, we are going to move that A into the H means nothing but one register. Okay, so the register H is having the value of first number. Okay, now our accumulator is empty, then go for next location, that is second number. Now second number is stored at the 20551. That number we are going to again move into the accumulator. Okay, that is A, right? So your accumulator is having a and register having the H. Okay, so now we are going to add them. Okay, so when we are going to add A and H, right, so the result will be stored into the A. So here the next, so we are adding A plus H and the result will going to store in the accumulator. Now whatever the result in the A, that we are going to move into the L. So move A into L. Okay, now that is next instruction MVI A00. So what? So we are moving the immediate value into the A. So we are making, or we are moving 0 into the A. Now why we are emptying that A? Because we have to add the carry, right? We have to add the carry, whatever the carry is generated we have to add them. So we are taking the next command ADC A. So what it will does, it will add the A, okay, plus whatever the result store into the A, that is A plus A and a carry. So total result will store into the A. Now we are moving that A, or value of the accumulator, that into the H. Okay, after moving that H, we are using the SHLD 3050, means whatever the result is generated, that is we are going to move into the our location, that is into the L, that will be exactly the result, and H is nothing but the total, sorry, the carry. And last is the halt means stop. We have to stop the instruction or program. So this is how the program will be written. So I will explain each and every step, each and every command, or we can say the instruction here. So first LDA 2050, in this moves the content of 2050 location at the accumulator. Now move H comma A means what? Copy the content of accumulator to register H to A. So whatever is the content in A, we can move into the H. Now LDA 2050. Now what? It moves the content of 2051 memory location into the accumulator. After that, after moving these two number, add H, okay, add H, add content of accumulator and H register. The result is stored in A itself. For all arithmetic instruction, A is the default and operand, and A store the result as well. Okay, so whatever A result, A store the result. Now move L comma A. So copy the content of A to the L. Now MVI A00 moves the immediate data, that is 00 to A. Now ADC-A, so add the content of A00, content of register specified, that is A, and carry 1. Okay, so all these, making the addition of all these three, and as ADC is also the arithmetic operation, A is by default an operand and A store result as well. So move H A. So whatever the result or the copy of content A, that will be moved into the H. So what exactly H? So H will store the carry, whatever the carry is generated, which is get stored into the H. Okay, so now SHLD 3050 moves the content of L register 34 in a 3050 memory location, and content of H register, that is carry, in a 3051 memory location. And the halt stop executing the program and halt any further execution. If you want to do any other operations, you can go for that, or you can stop. Okay, so this is how the 2-bit addition number can be performed. Now we'll go for the second program here. So 8086 program to find the maximum of 2 8 bits, maximum of 2 8 bits. So we write the assembly program. So here are two numbers. Suppose example, in the location of 50, okay, in the location 50, there is, sorry, in the location 2050 the number 50 is stored, and 2051 25 is stored. So whatever the output will be 25, and it will be stored at the location of 3050. Okay, so how exactly the algorithm? First we will load the value of into the accumulator. That is very first step, that whatever the values we have to load into the accumulator. Then copy the value of any value in the register. Okay, copy the value to any of the register. We have to copy those value into the register. Then load next value in the accumulator. Okay, first whatever, suppose this is a in the store in the accumulator, then we move this whatever the value is a into the h in other register. Now load next value in the accumulator. Now we will load the next value that need to be compared, and compare both the values. So we are comparing both the values. So now in the accumulator having the second value, and the h is having the first value, so we are comparing them. Okay, so which is a larger or which is smaller. Now check a carry flag. If reset, then jump to the required address to store the value. Okay, copy the result in the accumulator and store the result in the required address. So this is how the exactly algorithm will be. So now we will see the program. So here, so first step, load the 2050. So whatever the address location at 2050, we simply load into the a. Okay, then move b comma a. So whatever the value in the b, a, that will be load into the b. So whatever the value in the a, that will move into the b. Okay, now what happened? Now your a is empty. Okay, now load 2051. So whatever the memory location is having 2051, whatever the value, we will move into the a. Okay, so now a is a 50. So now compare. Okay, so compare instruction will simply compare the two numbers. Okay, so it will compare the accumulator with the register. Okay, so always recent operation happen with the accumulator. Okay, so there is no need to mention the accumulator all the time. So whatever the operation will be related or happen with the accumulator, so we have to just write the b. So whatever the value in the b and whatever the value in the a, that both will be compared. Okay, JNC 200C. So jump if carry flag is reset. Okay, if the carry flag is 0, okay, then it will jump. Okay, now move a comma b. So carry flag is generated means what? So which is the higher, so it will compare. Okay, suppose carry flag is 0, so it will be reset. Okay, now move a comma b. So whatever the value into the b, that will be moved into the a, because now after the comparing operation, so your accumulator will be set with the higher number. Okay, so whatever is the higher number, which will be stored into the accumulator. So whatever the value into the accumulator, that will move into the it will be give the value higher value. So whatever the value of higher, that will be come into the accumulator. Okay, now we will store that in a location 3050. So we simply whatever the value in the accumulator, that will be move into the location of 3050, and the rest is a halt. So program will be terminated. So this is how the simple execution of the program. So here is the explanation how exactly step by step. I will explain you again. First, load 2050. Load the value at a memory location 2050. Assign a value of b, assign the value of a to b. Okay, because we have to make the a empty for the next value. Again, load the next memory location value into the accumulator. Now compare both a and b. Okay, and now jump 200C means what? Jump at a memory location 200C if carry flag is reset. Okay, if the carry flag is reset. Now store the result in the memory location 3050. Okay, so this is how the simple execution of the program. So we will see another program, one more program, 8086 program to swap the two 8-bit numbers using the direct addressing mode. Okay, direct addressing mode means where direct by using the address we are swapping the numbers. Two numbers we have to swap means I will interchange the numbers. So what is the statement of the program? So write a program to swap two 8-bit numbers using a direct addressing mode where a starting address is 2000 and the first 8-bit number is stored at the 3000 location and the second 8-bit number is stored at the 3001 memory address. So here what is the input data? So at 3000 there is a 12 is stored, and in 3001 31 is stored. So there are registers D and H, these are nothing but the registers, suppose. And what we have to do, we have to interchange them. Okay, we have to interchange them. So whatever at the location of 301, we have to swap in the location of 31. Okay, so in the location of 3000. Okay, so you can see here 31 and 12 is a interchange here. So we are going to see the programming. So first we'll see the algorithm. So algorithm is same. First load the 8-bit number from memory location 3000 to accumulator. Okay, now move the value of accumulator into register H. Okay, so whatever is the A, it will come into the H. Now load the second value, that is from the memory location 3001 to the accumulator. After moving that, we are simply move the value of accumulator into register D. Okay, because again we have to swap the value, so we have to empty the accumulator, and for that purpose we are moving the value of this 3001 into the D. Now again the accumulator is empty. Now exchange both the registers PR. Okay, we are simply exchanging the, so there is exchange command we are writing, and we are writing the stop. So here is the program. So load first whatever the location at A. Okay, so sorry, location of 3000, that will be moved into the accumulator. Okay, so operand is 3000, so LDA, so it simply load the value into accumulator. Now we are moving that value of accumulator into the H. Okay, so whatever the accumulator is 12, suppose, that will move into the H. So your H is having 12. Okay, then load the next value, that is 3000 A. So your A is having 31, right? So we are again, we have loaded the next number. Now move A into D. Now what is having the in the accumulator? In the accumulator there is a 31, that will move into the D. So your D will become 31. Now your accumulator will be empty. Okay, now exchange D and H. Okay, so we will move exchange this L and DE. So whatever is the we are taking that register exchange. So whatever the value in the D, okay, it will come into the H. So your H will become 31, and whatever the value in the D, your D will become 12. Okay, so after that your instruction or your locations, data locations will be sorry, locations will be same, but your data will be exchanged. Okay, so in the last we will stop. So here is simple explanation. So explanation is what? A register A, H, D are used for the general purpose. Okay, they are general purpose registers, so their programmers can use them. So I would, so many times I explain you while doing the while explaining the architecture of the 8086 microprocessor, these are the general purpose registers. Okay, so LDA is used to load the accumulator directly using the 16-bit address 3-byte instruction, and move is used to transfer the data, and exchange is used to exchange the data, both the register pair H, L, D, E, 1-byte instruction. Okay, so you simply exchange the data. Okay, and HTL, HLT is used for the halt the program or stop the program. So this is how the programming of 8086 microprocessor. So in the coming lecture we are going to see more programmer like logical program. So this is not enough for you, because due to online lectures this is not possible to explain each and every program. So you have to go through the different programs, and you can perform using the in the 8086 microprocessor emulator. Okay, so you can perform in the editor of 8086 microprocessor. You can go for the different programs. Okay, so this is that enough for today. So thank you very much.